In grading projects, controlling cut and fill quantities can be a major challenge, especially on complex terrain. Unbalanced earthwork volumes can increase hauling costs and make grading decisions more difficult. In this video, AXANH will show how an earthwork map in Civil 3D helps visualize cut and fill conditions, evaluate earthwork balance, and optimize design elevations more effectively. To address these challenges, AXANH has developed an earthwork analysis workflow that helps visualize cut and fill distribution, evaluate earthwork balance, and optimize design elevations to reduce construction costs. Instead of relying only on quantity tables or static drawings, this workflow presents technical information in a graphic format that is easier to understand and review. Implemented on the Civil 3D platform, the solution uses survey data and grading design information provided by the client. By combining terrain modeling, volume analysis, and color mapping, AXANH helps project teams make more confident design decisions. At the first stage, the AXANH team creates the existing ground surface, or EG, from topographic survey data to accurately represent the natural site condition. This step is critical because the reliability of the entire earthwork analysis depends on the accuracy of the existing terrain model. A dependable existing ground surface becomes the foundation for all calculations that follow. Next, the finished ground surface, or FG, is developed based on the approved grading design. This surface represents the final elevations of the project after construction and reflects the design intent, including grading requirements, drainage considerations, and platform levels. In simple terms, it shows what the site is expected to look like once earthwork activities are complete. Once both surfaces are completed, AXANH engineers create a volume surface by comparing the existing ground and finished ground models. This makes it possible to determine the extent and quantity of cut and fill across the entire project area. At this point, engineers can clearly identify where excavation will occur, where fill will be needed, and how the site will be reshaped during construction. However, numerical data alone is often not enough for quick and effective decision-making, especially on large or complex sites. That is why the next step is to create the earthwork map using depth range analysis. The results are displayed through a color-coded system, making it easier to identify deep-cut areas, high-fill areas, and zones with only minor grading adjustments. Compared with conventional drawings or quantity tables, this drawing provides a much clearer overview of the site and helps engineers quickly recognize critical areas. Along with the visual analysis, the design team reviews the total cut and fill quantities to evaluate the overall earthwork balance. If the volumes are not yet optimized, the engineers will adjust the finished ground elevations to improve earthwork balance and minimize soil transportation costs. The final result is a clear and comprehensive earthwork map that shows both the extent and intensity of cut and fill across the project. This drawing plays an important role in grading design, quantity control, cost estimation, and coordination among designers, contractors, and stakeholders. At AXANH, we believe that effective grading design is not only about achieving the required final elevation, but also about creating a solution that is practical, efficient, and economical for construction.